Chapter 6, Visual Attention. We have been focusing a lot on the first 5 chapters, really on the basics of how mostly vision works, right? So the ways the retina takes in information to the brain, how that processing occurs. We talked a little bit about how we do scene analysis. Now we're going to start focusing more on some specific properties, some specific processes that enable us to process visual information. Okay, some of the more uh, interesting aspects of processing vision. And one of the first things you approach in this area is attention. That is, focus. How do we decide where to focus our attention, right? So, some of the things we're going to be dealing with here are why do we pay attention to certain parts of a scene and not other parts? Also, once we focus attention on something, what does that do, right? Does it make it stand out? Does it change the way we perceive it versus when we don't focus attention on it? And then finally, do we have to focus attention on something in order to perceive it? Is it possible to perceive things that we do not focus our specific attention on? So, scanning, right? So you guys remember what a scene is, right? So a scene is an image in front of us that we have access to, that we can perceive. And one of the things that we do when we look at a scene is we scan it. Right, we scan it and we look around from place to place. When we see something interesting, we fixate on it. When we see something that stands out or that we want to focus our attention to, we fixate on it, and that means to stop scanning and focus your gaze upon something that you're interested in for some reason. One of the things that our eyes do as we're looking at a scene or we're scanning anything is this saccadic eye movement. And that's basically where the eyes are going back and forth, constantly scanning a scene. Even when we're focused on something very specific, your eyes are making very minute saccadic movements. And this is to keep the image refreshed on the retina. If you did not do these saccadic eye movements, you would and you didn't and the scene didn't change, you would have the same image burned into the same spot of the retina, and eventually those neurons would become depleted and unable to fire. So the saccadic movement enables the image to be projected onto different spots of the retina, different spots of the fovea on a constant basis. Overt attention is when we are involves directly looking at something that we want to attend to. So it's when we focus our attention, we say, that's what I'm going to look at. And then covert attention is when we are attending to something, but we're not directly looking at it, right? So we all do this all the time, right? If there's for example, if there's somebody in the room who you don't want to communicate with, but you want to make sure you know where they're at. You kind of look away, but you're kind of paying attention to where they're at, right? That's covert attention. This picture's from your book, and the question is, where is Justin Bieber, right? Apparently he's in this image somewhere, and I'm not exactly sure where he is. There's a lot of people in this image, but is Justin Bieber in this image? How do you find that out? Well, we scan, right? We do a scan across, hitting all the faces as we can and trying to identify, looking for those things that we um, associate with Justin Bieber, right? So we do this scene analysis and we scan, we look, we scan, we look until we find our target. And I'm not finding him. Oh, there he is, right there. There he is, right there. There's Justin. All right. So I don't know if he's been photoshopped in there or not, but anyway, there he is. So after a while, you find him in the search, right? So you do a search by scanning the image or by scanning the scene, and then you find your target, right? So here's an example of looking at looking at this statue, right? And one of the things we can do in this type of research is we are able, in fact, to track eye movements. There is equipment that research equipment that you can buy that allows you to track where people are looking at when they're looking at a monitor, when they're looking at a screen or looking at a photo. So this picture here gives us an example of uh, of some of the information that you can get out of being able to track somebody's information. So somebody looks at this image, and the first place they fixate their gaze is right here, right? So they see this rooster up here. Then they quickly go around and do a quick analysis, looking at each of the major components, right? So I look at the horses, look at the statue, right? Coming over here and looking at the lamps, just getting an idea of what's here and what are the major parts of it, right? So we're doing a quick analysis, and we tend to focus on different things. For example, if there was a person standing here, we would spend time looking at that. If there was a very attractive person here, we'd spend even more time looking at it, depending on how attractive they were, right? If there was something unusual here, like a little toy car or something here in the water, we would spend a lot of time focused on that, and we can track all of that by following the gaze, the way we scan across a particular scene. This is we see this a lot in professional sports. This idea of focusing your covert attention, right? So basically, you're looking in one direction, but in fact, you're focused in another direction. Um, Point guards in the NBA, for example, will do this, instinctively, right? They will be, pushing the ball up the court and looking in one direction, but then pass the ball in another direction where they're expecting there to be one of their teammates, right? It's and they do this because one of the things that we do when we're processing and looking at other people is we look where their gaze is. We look where they're looking, right? We do it instinctively, right? So whenever the opposing team is looking at a point guard who's got the ball and is pushing the ball up the court, they're going to be looking at where that point guard is watching, because there's one of the things their unconscious processes are telling them is wherever he's looking, that's where the action's going to happen. But of course, a good point guard knows how to divert that attention, look one way and yet pass the ball in another direction where a play is going to be set up. Um, so what is it that grabs our attention, right? How do we focus? How do we know what to focus on, right? Or how do we decide what to focus on, I should say? So, what is it about a scene that causes it to focus our attention? Well, one of the number one things that's been studied and known for a long time that is the stimulus itself. So there's something in the scene that has certain properties of it that attract our attention. Color, maybe it's got a different color than the rest of the scene. Contrast, or it's oriented differently. These are things that we focus on. Um, the saliency maps, in other words, those maps of where we're looking and where we're tracking. Those are the first things that we focus on, right? Are things like color, contrast, and orientation. And also we'll talk about this later, but we do focus special attention on faces and people as well, right? But we do look for those sorts of things that stand out, like color, for example, right? And here's a good example, right? Here's a bunch of white folks, right, standing around looking at, I don't know what they're looking at, but they all look pretty uniformly the same, except for this one guy here. Right, this one guy here stands out in this scene because he's wearing a red shirt, as opposed to everybody else who seems to be dressed more in a light color, right? But scanning across this scene and looking at it, that guy stands out pretty well. Another guy that kind of stands out is this dude here, right? Everybody else is dressed kind of casually, but he's wearing a tie, right? He seems to be wearing a tie, and everyone else sort is more or less uniform. Um, One of the ways that you can build a saliency map is really to take an image and filter it in such a way that the things that are different stand out, the contrasts stand out, right? So, for example, here we have a scene of a beach, right? And when we do a saliency map, what we're doing is we're reducing the resolution of the image such that it's black and white, and only those things that are of a high contrast are going to stand out. In this example, it's the clouds and the shore, the actual waves breaking on the shore, and then a little bit of this island out here in the middle of the bay or the ocean, right? So in this particular example, right, we would say that the saliency, in other words, the most salient things, the things that are most interesting, in this particular image are going to be, the shore and some of the clouds, right? You probably wouldn't focus a lot of attention here. This is kind of boring, and the water's kind of boring. We're going to be looking more at where these things stand out here. And one of the ways you can do a quick saliency analysis is simply by blurring the image, reducing the resolution, and seeing what remains, what stands out. Um, of course, since we're humans, right? Since we're humans, we have language. We have language, which so that means we probably make a lot of our selection of what to focus on based on cognitive factors, based on language and meaning, right? And what we have, right? Well, it turns out that the what we bring to the prior knowledge that we bring to any particular scene or experience influences what we fixate on, right? So the things that we expect to see and the things that we don't expect to see, the things that we can name and the things that we cannot name, also influence what we fixate on, right? Also influence how we focus on things. So it's not just the bare image, right? And the things that are different colors and different contrasts. It's not just that. It's also what we focus on is also based on our expectations. And this prior knowledge in the world of visual attention is called the scene schema, right? In other words, whenever we see a particular scene, right away we have an idea as to what we expect to see there, right? So if I show you a scene of a big city, right, like a city, a landscape of a city, with all the buildings and everything, immediately you expect to see certain things. You expect to see buildings, and you expect to see some clouds, and you expect to see maybe even if it's a particular shot of a particular, maybe even some cars and little people, right? What you wouldn't expect to see there would be something like a farm tractor, right? If I showed you a shot of Midtown Manhattan, you wouldn't expect to see a farm tractor chugging along, right? If you saw that, you would fixate on it immediately and go, well, what's this thing doing there, right? So one of the things Shinoda, right, did this experiment. Let me see if there's a picture. No. So this experiment is described in your textbook on page. Let's see. It's a pretty cool experiment, but okay. So basically, and this has happened to me, right? um, Stop signs, right? Stop signs. We are more likely to detect stop signs when they're placed at intersections, right? And Shinoda tested this by having people driving in a driving simulator, and then have stop signs placed at the normal places. So as you're driving up, you see a stop sign at an intersection. But then he also set up this driving simulator so that stop signs are just like placed randomly, like on the street. So you're just driving along, and there's a stop sign. Um, and people are much less likely to perceive stop signs when they're placed in unusually non-expected places, because that violates our schema, right? That unless for some reason you live in a place where stop signs just pop up randomly, on the street, then you're not going to be used to that. And as somebody who travels a lot, this happens to me when I'm driving in a different place, and like I'll be driving around all of a sudden, and I don't know, I've never driven in a particular place before, and if a stop sign appears where like for a pedestrian crosswalk or something, some places do that, and I'll just I'll almost run it because it's not at an intersection.